Hey, what if I told you that your friends will have more number of friends than you do? You'll be surprised, right? But statistically, it can be proven that indeed your friends will have more number of friends than you have, no matter who you are. In this video, we'll see how we can prove this by using statistics fundamentals. But before we move on, let's see how a friendship network or a friendship graph may look like. Let's take the example of the famous TV show Friends, where we know there is a funny character named Joey. Let's say Joey is friends with Monica. Now, Monica has two friends named Rachel and Ross. There be Phoebe, and Phoebe is friends with only Joey. And we know there is Chandler, who is, let's say, friends with both Joey and Monica. So, this is called a friendship network or a friendship graph where we get information about which person is friend with which other persons. So in this graph, Monica has four friends, so we can write f of m as 4. Similarly, f of j will be 3. Now let's generalize this concept a little. Instead of 6 persons, let's say there are n number of persons now, namely 1, 2, and so on up to n. Now let's say the ith person has fi number of friends. So how many friendships will be possible in this network where there are n number of persons? So you can easily say this is sum over fi, and let call this f. Now let's pick a person completely at random from this n number of persons, and that person be x. What is the probability that x is I? As this person was picked up completely at random, all has an equal probability of getting picked up. So this will be 1 by n. Now let's calculate and what is the expected number of friends this randomly picked person x may have. We can denote this as expectation of fx, as f of I is the function denoting how many friends this person I has. So if you expand this expression, it will be nothing but sum over fi into probability of x equal to I. This comes from the definition of expectation of any function. Now as we know that probability of x equal to I is nothing but 1 by n, and therefore this expression eventually becomes equal to f upon n. Now let's discuss a different scenario. I will omit this part for now. So let's consider this scenario that each of these n persons are asked to write their friends' names in different sheets of paper. I mean, so let's say this person 1 has 5 friends, namely A, B, C, D, and E. A, B up to E. So he will write his friends' names in 5 different sheets of paper. He will write A here and write E in the 5th paper. Likewise, the ith person will write his friends' names in A5 sheets of paper and so on. So, how many papers will be there? You can easily understand the number of papers is just sum over Fi, that is F. Now, let's choose one paper completely at random from these F pieces of paper and let that paper be Y. What is the probability that the name I will be written on that paper? If you think a little, you will be able to understand that the number of papers where I will be written will be F of I, because the ith person has Fi number of friends. So there will be Fi persons who will write I's name on different sheets of papers, and the total number of papers is F. Therefore, the probability becomes F of I by F. Now, if we want to calculate what is the expected number of friends the person whose name is on the chosen sheet of paper has, what will you do? We'll have to calculate this quantity, expectation of Fy, because Y is the randomly chosen paper where the name I is written. So expectation of Fy denotes the number of friends or the expected number of friends this person I has. Now if we want to calculate this quantity, we have to expand it like this. This is sum over Fy into the probability of Y equal to I. And from the previously calculated expression, you see that the probability is Fi by F. Therefore, this quantity becomes sum over F squared by I by F. Now, if we multiply both the numerator and denominator by this probability, what do we get? We get something like this. If you remember, F is nothing but sum over Fi. Therefore, this becomes this. Sorry for a typo here. So there should be a P. Whatever, we get this expression from this expression. Expectation of Fy equal to this expression. So this expression essentially means this is expectation of F squared x divided by expectation of Fx. Now there is an inequality which says expectation of F squared x is always greater than or equal to expectation of Fx square. How do we get this inequality? Well, this inequality comes from the expression of variance. This minus this is the variance, and variance is always greater than equal to 0. So from there it follows. So we can say that this expectation of Fy will always be greater than or equal to expectation of F of x. So what does this expectation of Fy represent? And what does this expectation of Fx represent? X is a person chosen at random from n number of persons, and Y is a member, a randomly chosen member from a randomly chosen friendship pair. So the expected number of friends that a randomly chosen person has is always less than or equal to the expected number of friends his friends will have, and that's why this follows that your friend on an average will have more number of friends than you. So this is what is called friendship paradox. It may have some limitations or it will not always follow in reality, but this is the average case scenario where in general you will see people always have a tendency to become friends with a person who has many number of friends. So in general people don't want to be friends with a loner. With respect to everyone, this is an average case scenario. This will not always hold and there are exceptions to it. So that's it. That's my video about friendship paradox was. Bye for today.